All right, guys. Welcome to the video on fractions. This will recap basic fraction concepts that you would have learned all the way back in primary school, and some new high school concepts as well, and applications of these fractions, such that by the time you're done with this video, you should understand fractions in and out. You should have a roadmap of where I think you need to be in terms of fractions for grade 8, 9, 10, and all the other grades when you start applying them in different ways. So for these videos, it's gonna be a series. It's we're gonna first I'm first gonna cover what are fractions. Then we're gonna move on to the different types of fractions that we find. Then we're gonna move on to the rules around adding and subtracting fractions. And then from there, we'll go on to the rules and conventions around multiplication and division of fractions. These two are very, very important. If anything, these are the most important part of these videos, because this is the key part of the application. When you hit grade 10, 11, 12, university, you're gonna have to have an innate understanding of these rules right here, because you're gonna find fractions in different forms in algebra, in geometry, and you need to know these rules, what to do, what not to do, etc. And then then gonna cover percentages and decimals, and then finally applications of fractions. So what are the different situations where we find fractions and where we apply these rules? All right, so without further ado, let's go on to the first part here. So what are fractions? In primary, you guys would have started learning about times tables and division, all right? And initially when they taught you to multiply, they'd say, okay, I want you to multiply 43 with 3, and you'd write it like this, and you do your little rules, and you figure it out that way. If I said, then I want you to divide 40 with 4, like there, that's a plus sign, uh division sign there, and then you do it like that. All right, and then as you went higher in higher grades, you um as you went in higher grades, you then started doing something like this: 3 divides into 60, and you do your division there. You'd be like, oh, okay, I know that 3 goes into 6 two times. 2 times 3 is equal to 6, and then you say minus 0, right? You bring that 0 down, and then so you know there. Ooh, I'm confused here now, but I think there's going to be a 0 there. You have to forgive me for forgetting this method, but it was something like this. This is division, right? This is division. And then, if you also remember, they taught you about division in other ways as well. They started teaching you guys about fractions. So, fractions is just another form of doing division, all right? They taught you likely through the pizza image, right? So they'll give you a pizza. They'll say, I separated the pizza into 3 pieces, right? If I if Francis eats one of the pieces, then he has eaten 1/3 of the pizza. And then they'll ask you, so how much, what fraction or what portion of the pizza is left? And then you guys will be like, oh, okay, I know that. That's 2/3 that are left. This one there and there, 2/3 left, right? And so this is your introduction into fractions. Fractions are no different from this form of division, because fractions are just a different way of writing your division. Essentially, you are saying, if I were to write this as a fraction, you would write it as what is 60 over 3, where 60 is your numerator, 3 is your denominator. And the language of fractions is telling you my numerator is being divided by my denominator how many times? All right, and our answer is naturally 20 times. So what does that mean? It means if I gave you 20 times 3, if I gave you 23s, then your answer would naturally be 60. And that tells you, and this should show you the relationship between division and multiplication. They are closely related because they are, I wouldn't say inverses, but they are, I guess, opposites of each other, for the lack of a better description. All right. In the sense that the ingredients you use to multiply are also the ingredients you're going to use for division, just in a different order. All right. Okay, so that's what fractions are. Let's go on to the types of fractions we get. So we've established that fractions are just another form of writing a division sum, right? They are a way of describing parts. Okay, I think let me not move on before I tell you guys about this. So fractions, let's do that. Fractions describe B parts and wholes. What does this mean? It means if I gave you that original pizza right there, and Francis hasn't eaten any of these pieces, there's still 1, 2, 3 pieces there, and I told you to write that as a fraction, you would write that as I have 3 pieces out of 3. And anything divided by itself will give you 1. So that means I have 1 whole pizza. But then if I now take 1 piece and I have 2/3 left, it's saying I have 2 parts out of a total of 3 left. That should be an F left. And that's what I mean by fractions describe parts and wholes. All right. You need to understand that any fraction, any proper fraction, we'll get into that, but any proper fraction is actually always going to be smaller than 1. Any proper fraction you come across will always be smaller than 1. And then you get a whole fraction, which will always be equal to 1. And then, so if you get an improper fraction where the numerator is bigger than the denominator, that will always be bigger than 1. So let's get into those details. What is a proper fraction? All right. A proper fraction is any fraction where the numerator is smaller than the denominator. So essentially, something small, a small number 2, for example, is being divided by a bigger number, which is, let's say, 7. Okay. Another thing as well, before I go on, it's also important to understand that fractions can be expressed on any number line. So if you guys think back to your number theory, where they tell you about real numbers, natural numbers, imaginary numbers, rational, irrational, you know that the real numbers is any number that I can write on my number line. Okay. So that includes negative numbers, that includes positive numbers, that's 2, and that includes fractions, because a half is also equal to 0.5. We'll get into that when we speak about our decimals, but it's also important to understand that a fraction is any number, or you can express any decimal as a fraction, and most decimals anyway as fractions, and you can write them on the real number line, all right? So that's just a quick bit of information there. So we've established that this proper fraction is any situation where your numerator is smaller than your denominator. But what does this mean? It means, like I said, I'll put that in red, it will always be be smaller than 1, or rather, let me write it down instead of using my symbols there. Smaller than 1 when it, like, in decimal form. All right, so what does that mean? If I put 2/7 in my calculator, 2/7, all right, and I convert that to a decimal, I find that 2/7 is an irrational decimal, a long decimal. It's 0.285, and it goes on and on and on, right? It doesn't recur, and it's non-terminating. That's supposed to be an 8, guys. Let me erase that because that looks like a monstrosity. 285, and it goes on and on and on. This number, this decimal, on the real number line is smaller than 1. We have 1 here, and 0.285 would probably be somewhere here. All right, so any proper fraction, you can try this for any proper fraction you ever come across, will always be smaller than 1. Of course, you can also have these proper fractions being smaller than 1, but also negative. So negative 2 over, why did I write 3 there? Ooh, so many errors. Okay, this is 2/7. Negative 2/7, right, is here on your number line. If this is 0, this is -1. Negative 2/7 will be somewhere there. All right, that's the decimal. It's negative 0. I think it was 285. It's right there on the negative side of the number line. All right, so that's proper fractions. And next, let's speak on improper fractions. Okay, so improper fractions are fractions that you come across where the numerator is now bigger than your denominator. All right, than your denominator. So for example, 6/2 is an improper fraction, because we're saying, essentially what this is saying is how many times does 2 divide into 6, but 6 is bigger. So what you will find, our rule actually is, we're saying it will always be bigger than 1 in decimal form. All right, what does this mean? If we've got 6/2, let's use our example there. We have 6/2. We know that 6 divided by 2 is 3, and 3 is definitely bigger than 1. If I said -6 divided by 2, that would be, if I said -6/2, that would be -3, and this would just be 3 on the negative side of the number line. All right, so that brings us to our final type of fraction. That brings us to mixed fractions. Now, mixed fractions are nice because they are actually the same as improper fractions, just written differently. Because if you notice, if you understand if you think back to our knowledge of fractions, let me just make a bit of space here without wasting too much time. Hold on. Okay. All right. Okay, so mixed fractions. Mixed fractions, they are improper fractions written differently. Okay, what does this mean? So if I give you the improper fraction, let's go with 7 over 2. This is an improper fraction. The numerator is bigger than our denominator. I would ask you the question, all right, how many times does 2 divide into 7 properly? And if it does, how many is there a remainder? All right. So you say, okay, Francis, I know that 2 can go into 7 3 times because 2 plus 2 plus 2 is 6. And then there is a remainder. There's a remainder of 1. So we can write this as an improper fraction. We write that as the whole number part of the improper fraction. Our remainder is 1, and our denominator stays the same as 2. All right. I want you guys to think back to your primary days. If you were given this, right, then you do exactly the same. You'd ask yourself, how many times does 2 go into 7? You'd say 2 goes into 7 3 times. 3 times 2 is 6. Then you say minus, and your answer is 1. So your answer would be 3, remainder 1. All right. So this is the general form of a mixed number. It has a whole number part, then it has a numerator, and then a denominator in the fraction. But what is it telling you? It's telling you that if this 7 over 2 here, right? So we have 3 and 1 over 2, right? It's telling you that I have 3 full pizzas, 3 wholes, right? Each whole is separated into 2's, right? Because our denominator is 2, so we're dealing with halves. So we have 1 half there, 1 half there, and a half there. And these are full, right? So we have 1, 2, 3, 4, 5, 6. And then I have an extra pizza that only has 1 half. So 7. And that's how we come to 7 parts, right? 7 halves. And if you look at the notation of our mixed number, we have 3 wholes and 1 extra half. 1 extra half. So it can be written as, essentially, you can actually write it as 3 plus a half. Okay, we're gonna get to our rules for adding and subtracting fractions, but 3 and a half, you can, if you add it, you're gonna have 3 over 1 plus 1 over 2, and our LCD will be 2, so we're gonna multiply this by 2. We're gonna have 6 over 2 plus 1 over 2, and then that's gonna give us 7 over 2. So do you see how all of these are interrelated? These are all interrelated. You can convert from a mixed number to an improper fraction, and from a proper fraction to a mixed number. They are two and the same. These are the same. All right. So now let's go to these conversions, because conversion is a very, very important skill. All right. Let's look at question 3a. All right. I hope you guys can see there. We got question 3a, right? So what are the rules for converting from an improper fraction? We have 19 over 7 here, and we want to make this a mixed number, right? Remember, you ask yourself, how many times does my denominator fit into my numerator? And I ask you guys, how many times does 7 go into 19? Well, I know that 7 times 2 is 14. All right, and 7 times 3 is 21, but 21 is bigger than 19, so I'm gonna go with 2, right? And what's 19 minus 14? 19 minus 14 is 5. That's my remainder over, and it's 7 parts. We're dealing with a fraction of 7 parts, and that's how you do it. If we can go again, we move on to, let's do B, right? B has 92 over 6. So you ask yourself, how many times does 6 go into 92? off the top of my head, I have no idea, but let's go. Let's start at 60. I know 6 goes into 60 10 times. All right? So let's go 60 plus 6, that gives me 66, plus 6 plus 6, 78. So 66 times 13 is equal to 78. I'm sure we can still fit more 6's in there. All right, so we have 78 plus 6 plus 6, 90. So we have 6 times 14 is equal to 90. Right, let's just verify that. Ooh, that's 84. Nah, my bad. 6 times 15 is equal to 90. So here we're gonna go, and 90 is just before 92. So here we're gonna go 15, right? And what's our remainder? 92 minus 290 will give us 2 over 6. All right. So that's how you convert from your improper fraction to your proper fraction. But now let's look at our conversions from our mixed fractions to our improper fractions to just finish off the video. All right. That conversion goes as follows. If we look at question 2a there, all right, we have 2a, all right, and that they give us there a mixed number fraction that is 6 and 9 over 11, and they say convert that into an improper fraction. So what you're going to do there is you're going to take your whole number, you're going to multiply it by your denominator, and then you're going to add your numerator. So you're going to say, it's a little equation. It's whole number, right, times your denominator plus your numerator. That's an M, your numerator. All right. So that's our little formula there for converting. So what's our whole number? Put that in a bracket. Our whole number is 6. We're going to multiply that with 11, right? And then that we're going to add 9. And that's going to give us 6 times 11 is 66. 66 plus 9 will be 75. And so your improper fraction is equals to 75, and your denominator remains the same over 11. And you can apply this to any other mixed number you have. It's your whole number times your denominator plus your numerator, and that becomes your new numerator. Your answer becomes your new numerator, and then over the same denominator. All right, guys, that's our first video. Next up, we'll be dealing with addition and subtraction of fractions. All right.